Right. Next we asked how many 6-digit integers which contain the digit 3 at least once do not contain the digit 5. So there are two sets and the complements of these sets which we are interested in here. Let's denote them as follows. S3, let that be the set of 6-digit integers which do contain the digit 3. And let's similarly denote S5 as the set of 6-digit integers containing digit 5. Then we can draw a Venn diagram of what we want. So here's set S3 and here's the set S5. And we want those guys that do contain 3 but do not contain 5. So it's that set which I'm shading over there. Now there's various ways to count this, but probably the easiest way is to do the following. I want the set which does not contain 5, so the complement of S5. But not the whole complement of S5, only a little bit of the complement which also sits within S3, that bit. So this is all in the complement of S5, but also in S3. So I could write here intersection S3. But of course S3 is not that easy to calculate directly. It might actually be easier to say, well, what I want is I want the complement of S5 and I'm going to take away the complement of S3. So the set here is the set of all 6-digit integers which do not contain 5. Take away those that do not contain 3. So what I'm left with is those which do not contain 5 and which do contain 3. And that's not so difficult to calculate, because that, we know, the size of that set is the size of S5 complement minus the size of the intersection of these two sets. S5 complement intersect S3 complement. Now S5, these are 6-digit integers not containing the digit 5, so reasoning similarly to as we did in the previous questions, we say there are 8 options for the first position of such an integer and 9 options for each of the other positions of the integer. So the remaining 5 positions each have 9 options, so that contributes a factor of 9 to the power 5 over there. Now, the integers sitting in here are 6-digit integers. Sorry, I made a mistake. That should be S3 complement. The integers sitting in here do not contain S5, and they do not contain 5, and they do not contain 3. So I'm constructing a 6-digit integer. I can't use 3 and I can't use 5. In the first position I can't use 0 either, so there's 7 options for filling the first position. And then for each of the remaining positions there are 8 options, anything except 5 or 3, and there are 5 remaining positions. And that is our answer.